Hello everyone, welcome back to my channel. In this video we will be discussing the probability and statistics 4th, 5th and 6th question from the Feb March 2020. So let's begin. So here's the question number 4. Richard has 3 blue candles, 2 red candles, 6 green candles. So altogether there are 11 candles. The candles are identical apart from their colors. He arranges 11 candles in a line. Find the number of different arrangements of 11 candles if there is a red candles at each end. So there are 2 red candles and they are at the end. So if the two reds are at the end, so we are left with only 9 places in between. Now in those 9 places we have to arrange the 3 blue candles and 6 green candles. So there are the total arrangements will be, there are 9 places, so 9 factorial, and 3 blue candles, so 3 are identically blue, so 3 factorial, and 6 green candles again, so it is 6 factorial. And we can simplify, it is 9 into 8 into 7 over 3 factorial, that is 3 into 2, and it is going to be 3 2 4 is 8, 3 3 is 9, 4 3 is 12, 7 is 84, sorry. So the total arrangement will be 84. I hope it is okay. Let's do the B part. B part is find the number of different arrangements of 11 candles if all the blue candles are together and the red candles are not together. So we can do in this way, like we will be restricting, or we will be putting only one condition on it, restriction on it. First thing, like only the blue candles are together. Blue candles are together and there is no restriction for red candles. So if blue candles are together and there are 3 blue candles, so altogether there will be, like we can consider these 3 blue candles as 1. So 8 plus 1, 9 are left, and in there are how many arrangements, now how many arrangements of putting these blue candles together, since they are identical, so it is 3 factorial over 3 factorial for blue candles, so only 1, and then for the rest of them will be 9 factorial over, there are 2 red candles, so in 2 factorial ways you'll divide by this, and 3 factorial for the sorry, not 3, 6 factorial for the green candles. So it is, we can simplify again, 9 into 8 into 7 over 2, and 2 4s are this, so 4 7s are 28 and 9 8s are 72, 9 2 is 18, 18 and 7, it is 25. So there are 252 different arrangements of putting the 3 blue candles together. Now what we are going to do, we are going to put 3 blue candles together and 2 red candles are also together. If they are together, then what is the possibility? Then again 9 candles were left, if you took 3 blue candles as 1, now if you are taking another 2 blue candles as 1, then there will be only 8 candles left. So how many ways, different arrangements, there are 8 places, and we know that 2 red candles are 1 and 3 blue candles are taken it as 1, so only green candles are to be arranged, and we know that there are 6 green candles, identical green candles, so different arrangement will be 8 factorial over 6 factorial, which is 8 into 7 into 6 factorial over 6 factorial is the 1 only, so it is 8 7 ja 56. So now if we subtract this arrangement when all the two red candles are together from the total number of arrangement when only 3 blue candles were together, we will get the arrangement where red candles are not together, and hence the required arrangement is equal to 252 minus 56, and we can subtract and see 12 minus 6 is 6 and 14 minus 5 is 9 and 2 minus 2 it become 1, so it is 196. So there are 196 different arrangement in which 3 blue candles can be together and 2 red candles will never be together. I hope it is clear. Let's do the next question. Here is a question number 5. In Greenton, 70% of the adults own a car. 70% of the adults own a car. A random sample of 8 adults from Greenton is chosen. Find the probability that the number of adults in this sample who own a car is less than 6. So we can see there is a two possibility only. Either this any adult will own a car or not. So it means it is a binomial, and here the probability is 70%. Probability of owning a car is 70%, or you can say 0.7, and so not owning, that is Q, will be 30%, and that is 0.3. and hence what we are going to find, we are going to find the probability. Let x be the number of adults who owns a car, so we can find the probability of x, the sample of 8, here n is 8, we can write n is 8, who own a car is less than 6. So less than 6, it is what we need to find. And we can see in place of finding the 1 2 3 4 and till 5, we can directly put it as 1 minus probability of x greater than or equal to 6, or you can say 1 minus probability of when x is either 6, 7 or 8. So we can find it with the help of binomial. So it is 8c6, we'll add them all. 8c6 p, that is 1 over, it is 0.7. so 8c6 p raised to the power 6 and q raised to the power 2 plus 8c7 p raised to the power 7 and q raised to the power 1 plus 8c8 and p raised to the power 8 and q raised to the power 0. This is a possibility, and now we will calculate with the help of calculator here. First of all, we will write one line for this. It is 28. Let's put the value. I'm replacing the value, and p is 0.7 to the power 6 and 0.3 to the power 2, and 8c7 is 8 and 0.7 raised to the power 7 and 0.3 plus 8c8 is 1 and 0.7 raised to the power 8 into 0.3 to the power 0, that is 1. So we will leave here, and now this is going to be, it is 0.55177 and so on. So I'm writing 77 till here, and which will give you 1 minus 0.55177. From the calculator we got it as 0.44823, and till 3 significant figure we can write our answer till 0.448. That is the probability that the number of adults in this sample who own a car is less than 6. In B part, it is given that a random sample of 120 adults, so which is more, so we'll be taking the approximation, and they have given also that use an approximation to find the probability that more than 75 of them own a car. And we know that this is earlier it was binomial NP, now it will be approximately we'll approximate to the normal distribution which comes with mu sigma square, and mu is the mean and sigma square variance. So let's find the mu and sigma. Mu is NP, which is 120 into P was 0.7, and that is 84. And variance sigma square is NPQ. NPQ, and it is 120 into 0.7 into 0.3, which is 25 and half, 25 and 2, 25.2. And now we need to find the probability when more than 75 of them, so we can write in the standard form with using z. It is going to be x minus mu. X minus mu means 875 minus 84 over sigma, not variance. Here we apply the sigma, that is standard square root of variance, and hence this is going to be 25.2, which we will find out. We'll simplify it more. It is z greater than, let's simplify, it is minus 1.693. Now we'll find out how to find this probability. We know if this is the normal distribution curve and this is the mu, if it is the mean is 84 and 75 will lie somewhere here, 75 will lie somewhere here, and you are finding more than that. So in standard form, in the standardized form, z is 0 and z here it is minus 1.693, and if you want to find this probability, means this area, we will simply calculate accordingly at this point, that is 1.693, and we know that area of this we can find with the phi of z. So probability of z greater than minus 1.693, it is simply phi of 1.693, and which is 0.955. It is from the table, from the phi table. It is given at the in the formula booklet. So this is the formula. This is the value for, this is the probability that more than 75 out of 120 own a car. I hope it is clear. So let's do the second question, next question. So here is the question number 6. A box A contains 7 red balls. A box contains 7 red balls here. This is A and this is B. So there are 7 red. I'll write red here. 7 red. 1, 2, 3, 4, 5, 6, 7, and 1 blue ball. So it is 1 blue ball here. And in the B box, it contains 9 red balls. That is 1, 2, 3, 4, 5, 6, 7, 8, 9 red balls and 5 blue balls. So 1, 2, 3, 4, 5. Now let's understand the question. A ball is chosen at random from box A and placed in B. A ball is then chosen at random from box B. The tree diagram below shows the possibilities for the colors of ball chosen, and we can write it here. We can see it is going to be red at the last, it is red blue at the last, here it is blue red at the last, and here it is blue. Now let's find the probability. Like, what is the probability of getting red ball from box A? So there were 7 red balls, so it is 7 over 8. And what is the probability of getting blue? It is 1 over 8. From here we can see 1 out of 8, 7 out of 8. And when it is placed in box B, now if you have chosen red, then the red ball become, earlier there were 9, now there are 10 red balls, so it become 10 over total, that is 15 here. Now earlier it was, there were only 14 balls, but now there are 15. And for blue number of blue balls are same, so 5 over 15 here. And when it is blue ball placed in box B, then the red balls in box B are of course still same, so 9 over 15, and blue ball is increased, so it is 6 over 15. So this is the tree diagram. I hope it is easy and clear to you. Let's do the B part of it. B part says that find the probability that two balls chosen are not the same color. So we can find the possibility here. See, not of the same color. At the last we have only these two possibility, so we need to find the probability here. So probability of either blue red or red blue, so it is like finding the probability of blue red, or means add probability of red or blue. And now let's calculate from the tree diagram only. What is the probability of blue from first box A? That was 1 over 8. And when we are taking the red from it, so red from it, we can see red from this, it is 9 by 15. So into 9 by 15 plus red ball from A box was 7 over 8, and blue ball from the B box B, it was same, so 5 over 15. Now we will calculate. It is 9 over 120 plus 35 over 120, which is 9 5 14, so 44 over 120. We can simplify, it is by 2, it is 22 over 60, and that is 11 over 30. So this is the probability of taking at the last beat when two balls are of not same color. So let's do the C part now. In the C part, it is find the probability that the ball chosen from box A is blue, given that the ball chosen from box B is blue. So it is, we can see it is a conditional probability. We'll use the formula directly. What is the probability we are going to find? Probability of blue from A, given that blue from B we get, it is chosen already. So there is a formula, so we'll write it like probability of getting like A will give B blue, intersection with B will also give blue. I'm writing in this way, it is completely fine to use any notation, and given B, or we can write blue ball from B. And now we have to use the conditions. We can see what is the probability when the blue is coming from A as well as, and intersection means and, from B. From the tree diagram we can see it was the last option. We can see the last option, it is either blue and blue, so 1 over 8 into 6 over 15. This is the first case. And what is the probability of getting blue? There are two cases, red from first and blue from second, that is 5 over 15, or blue from first and blue from second, so it is 6 by 15, right? So that is the only case. Now we can simplify it. It is, we can see 3 2 the 6, 3 sorry which can be simplified, and we'll write the last answer 6 over 120 here upon, let's take the LCM as 120, and here it is 35 plus 6, and 120 is cancelled with 120, and it is 6 over 35 plus 6 is 41. So the answer is 6 over 41. We can write in the decimal as well. So 6 over 41 is 0.1463, so 1.46. That is the probability. I hope it is clear. So we will be discussing the rest of the question, like last question, in the next video. Thank you.